Good afternoon to all of you, those who are present over here. My name is Satish Yadav, and today we'll go and we'll try to see about the new topic. I came up with the new topic into the combinatorics, and that is called as a Euler totient function. See, Euler totient function is very important with respect to the computer science point of view, and you can say that Euler totient function is also very important with respect to into discrete mathematics, or you can say that into combinatorics, and it is also very important in terms of what? In terms of, you can say that in terms of computer network. So this is also very important in terms of a computer network, and this is also very important with respect to the discrete mathematics point of view. So let me tell you first about the combinatoric Euler totient function. Euler totient function is a mathematical structure that is used to count something. So I just want to have you the curiosity about the Euler totient function. When you will have the curiosity about the Euler totient function, then you can understand, you can say the basic principle regarding it. Hardly it will take 20 to 30 minutes in order to calculate what? In order to calculate the Euler totient function. So, but before that, understanding the Euler totient function, let me tell you about myself. My name is Satish Yadav, and I am having more than 8 years of experience, and I have taught more than 1 lakh of students. My area of expertise are discrete mathematics, DBMS, digital logic, and ICT. ICT for ESE. So those people who wants to prepare for ESE, I teaches ICT for those students, civil, mechanical, EC and EEE. Now I have also having a lot of, you can say that experience into the research with many MNCs. And before that, let me tell you about, the preparation regarding, which is nothing but called as about any particular examination. See, in order to clear any particular examinations, we will require the certain things. What are those certain things? Let me tell you about those certain things. The first one, that is called as a planning, strategy, and then you will be having the goal. You will be having the dedication, consistency, practice, revision and revision. This revision many times, re-revision, you can say that. So these all things are very much needed in order to do what? In order to go for a, you can say that in order to go for a to clear any particular examinations. So the first thing that we have to understand, who will be telling us to do the planning. So Gradeup is coming up with one particular plan. So here you can see that all of the plans are existing. So here you will be having 600 plus of live classes, 5000 practice questions you will be getting. So if any person will be asking, sir, can you give me any particular mantra such that I will be getting less than 100 rank into GATE examination? Then I can tell you this particular thing. And what is that? The main important thing over here you will be getting is something like this, such that if you will solve more than 6500 of questions, then you will be getting what? You will be getting a good rank. But here if you try to see that, here the Gradeup is providing you 5000 plus types of questions. So 1500 questions the faculty will be covering into the live classes if you will be taking all these types of subscription. So here you will be getting what? Here you will be getting hundreds of mock tests, and then you will be getting hundreds of chapter wise study notes. These all are the facilities that you will be getting into the Gradeup. Gradeup is providing you the structured plan. What is that structured plan? Such that the Gradeup is giving you whole year plan. So from, you can say that from March to till November. So Gradeup is giving you the whole year plan so that you can plan your study accordingly. Suppose in March or in April, June, July, whatever the month will be there. Suppose if you're taking any particular subscription and if you're coming into any particular batches. So over here you will be, for example, 8 to 10 a.m. every day. So the faculty is coming and faculty will be live on 8 to 10 a.m. every day, and he will be teaching you many concepts regarding that. And then you know that every day from March to November, you know that every day 8 to 10 the faculty is coming, and then you have to sit in a class. After 10 o'clock you are free. Now you can do the revision, you can go and you can try to solve the questions, and you can practice a large amount of new questions, or you can also solve the GATE questions. So everything is related to this particular thing. So this structured plan, who will be giving? The structured plan will be given by the Gradeup. So this is the basic concept of what? This is the basic concept of a structured planning or a structured study strategy. So it's very important. Okay, very good afternoon, Harinath. Okay, so it's very important to go and to have the structured study plan throughout the year. Now if you will have the structured plan, you can plan the whole year syllabus accordingly. Okay, But before that, let me tell you, or let's try to understand about that topic. And this topic is basically called as what? This topic is basically called as a Euler totient function. First of all, what is Euler totient function? We'll go and we'll try to understand. See, whenever I will be writing Euler totient function, this is a representation with respect to the Euler totient function. So what is a Euler totient function? If anybody will be asking what is the Euler totient function, then you have to say that it is basically counting the number of, the number of relative prime, or you can also say that number of a co-prime which is less than or equal to n. Number of co-prime, or you can also call it as a number of relative prime, which is less than or equal to n. So basically this is called as what? This is counting. Here you are counting something, number of a relative prime. So the first thing that we have to understand is basically what is a relative prime. The relative prime, if anybody will be asking, either you can call as a relative prime or you can also call as a co-prime. So either you can call as a relative prime or you can also call as a co-prime. So actually whenever you will see the totient function of n, the totient function of n, what it is trying to say that you have to go and you have to count how many relative primes will be there which is less than or equal to n. So let me tell you about that particular concept, such that relative prime, it is also called as a co-prime. So if anybody will be asking what is a relative prime or a co-prime, then you have to say that if GCD of any two elements that you will be getting is basically 1, then A and B are called as a co-prime or A and B are called as a relative prime. So here A comma B are called relative prime, or they are also called as a co-prime. So basically the Euler totient function is to calculate the relative prime or to calculate the co-prime which is less than or equal to n. So let's try to take some example. Suppose what will happen if I will be writing totient function of a 3. So in this totient function actually we are counting something, and what we are counting which is nothing but number of elements which is less than 3, how many relative primes are existing. Now let's try to consider how many numbers, positive integers, that will be less than or equal to 3. So here you will be getting 1, 2, 3. Now if I want to calculate about 1, 2, 3, now first try to put the elements into that. Now suppose, can I say that 1 will be coming? We have to count something. Can I say that 1 will be coming? So let's try to write it down. GCD of 1 comma 3, here you will be getting as 1. Now what about that? GCD of 2 comma 3, what I'll be telling that you will be getting 1. But what about GCD of 3 comma 3? So GCD of 3 comma 3, you will be getting what? You will be getting 3. So how many relative primes are existing over here? If you will try to see that this is one particular element, this is another particular element, so you are getting 2 relative primes which is less than or equal to 3. So whenever someone writes totient function of 3, then the answer you will be getting is basically 2. So what it signifies? It signifies that how many relative primes are there, how many number of relative primes which is less than of 3 will be available. So you can say that only 2 numbers are there. And what is that or what are those 2 numbers? The 2 numbers you will be getting is 1 and 2. So in this way we can go and we can try to calculate. Now suppose if I will try to understand, suppose let's take another example. So here if I will try to find out such that what is the GCD of, or what is the totient function of a 4. So if I want to calculate the totient function of a 4, then what you have to say that totient function of a 4. So let's write down all the elements. So here you will be getting 1, this will be getting 2, this will be getting 3, and then this will be getting 4. So as I have already told you, if any person wants to understand what is the totient function of n, then it is saying that number of elements which is relative prime, number of elements which is relative prime to n. Relative prime to n. Now if, as I told you, if anybody will be asking what is the relative prime, then you have to say that relative prime is basically defining as such that if a GCD of a comma b, that you will be getting as what? That you will be getting as a 1. Then that is called as what? That is called as a relative prime. So let's try to understand over here. Suppose, can I say that one element will be coming? Obviously the first element you will be getting, such that GCD of 1 comma 4 you will be getting as 1. So 1 we can count 1. What about 2? So suppose if I want to calculate with respect to GCD of 2 comma 4, there here you will be getting 2. So 2 will not be coming into that picture. Now what about the 3? So can I say that GCD of 3 comma 4 that you will be getting is basically 1. So 1 will be coming into that picture. So can I say that 1 is a relative prime to 4? Yes. Can I say that 2 is relative prime to 4? No. Can I say that 3 is relative prime to 4? Yes. Can I say 4 is a relative prime to 4? No. You know why? Because here I can write such that GCD of 4 comma 4, what you will be getting? You will be getting 4. So that is why it does not comes into the picture. Now what will happen? Here, how many relative primes that I will be getting? This is first element, this is second element. So here the answer will be coming as a 2. So as we can see that in the previous one, totient function of 3, again we are getting answer as a 2. Now if you will try to see that here, totient function of a 4, again we are getting answer as what? Again we are getting answer as a 2. Now let's take another example. Suppose what will happen if I will be writing something like that, such that totient function of what? Totient function of a 12. Suppose if I want to calculate totient function of a 12. So how many elements that I will be writing here? So as you can see that this is 1, this is 2, this is 3. First we are calculating manually, and then after that we will go and we will try to understand about the other things. So 1, 2, 3, 4, 5. And then you will be getting 6, this you will be getting 7, this will be getting 8, 9, 10, 11 and then 12. First we will try to calculate manually. As I have told you, totient function is basically trying to say you what? Totient function is basically trying to say you how many relative primes would be possible. As you can see that the first element that we can say that it will be coming into that picture, 1 comma 12 you will be getting as 1. So we can say that 1 is relative prime to 12. Now what about this? 2. So can we say that GCD of 2 comma 12, what you will be getting? You will be getting 2. So this will not be coming into that picture. What about 3? Can we say that the 3 will be coming into that picture? 3 comma 12 you will be getting as a 3. So we can say that 3 will not come into that picture. Can we say that 4 will come into that picture? Again the 4 will also be not be coming into that picture. Can I say that 5 will come into that picture? Yes. You know why? Because the GCD of 5 comma 12, what you will be getting? You will be getting as a 1. So 5 will come into that picture. Can I say that 6 will come into that picture? No, 6 will not be coming into that picture. Can I say that 7 will come into that picture? We can say that the 7 will be coming into that picture. You know why? Because GCD of 7 comma 12 you will be getting as a 1. So 7 will be coming into that picture. Can I say that 8 will come? No, 8 will not come. Can I say that 9 will come? 9 will not come. 10 will come? No. Can I say that 11 will come? Obviously the 11 will be coming over here. So now we can say that GCD of 11 comma 12, what you will be getting? You will be getting as a 1. What about 12? 12 will not come into that picture. So if we will try to calculate over here, what we will be getting? This is first element we will get, and then we will be getting second element, we will be getting the third element, and then here we will be getting the fourth element. So if we will try to calculate the GCD of a 12, what we are getting answer? We are getting answer as a 4. So now this is one method. Right now we are calculating manually, but what will happen if I can write? What will happen if I will write GCD of our totient function of a 12? Answer we are getting as a 4, but I can also write totient function of a 12 that can be written as totient function of a 3 into 4, and we know that totient function of a 3 into totient function of a 4. Here what we will be getting? We will be getting 2 into 2, that is also going to be 4. See, in the previous slide only, as we can see that in the previous slide, as I'll write one more time, totient function of a 12 that can be written as 3 into 4, and then this can also be written as totient function of a 3 into totient function of a 4. In the previous slide we have already seen that totient function of a 3 we are getting as a 2, and totient function of 4 we are also getting as a 2. So the total answer that we are getting is basically 4. Now let me tell you this particular thing. Euler totient functions are multiplicative in nature. What is the meaning of a multiplicative? So here you will be having the totient function of a into b. You can also write as totient function of a and totient function of a b, where a and b should be relative prime to each other. This is one of the important concepts that you people can have with respect to the totient function. So we can say that a and b are relative prime, are relative prime. we can say that A and B are relative prime to each other. So in this way we can go and we can try to understand about what, in this way we can go and we can try to understand about A and B are relative prime to each other. Now let's see that the other thing. What about the prime number? Suppose if I will write what is the totient function of a 7. So if I will try to calculate manually 1, 2, 3, this is 4, this is 5, this is 6, this is 7. Sir, I am having a one doubt. What will happen? Right now you are calculating manually. Let's consider the totient function of a 12. Let's consider the totient function of a 7. Let's consider the totient function of a 6. But what will happen if a totient function of 200? What will happen if I will be taking the totient function of a 300? So if the numbers are very large, we cannot calculate manually. We cannot go and we cannot perform the same operation to each and every element. So at that point of time, what we will be doing is basically, okay, at that point of time, what we will be doing, we will be trying to, come up with one formula. So how we can come up with that formula? So in order to do that, I am doing all the things. So before that, just we have already seen one particular formula, and what is that? Such that totient functions are multiplicative in nature. So totient function of A into B, that can be written as totient function of A into totient function of a B. Okay, totient functions are multiplicative in nature. If I want to calculate with respect to, let's come up with another example. What will happen if I want to calculate with respect to totient function of a 7? So here totient function of a 7, how I can calculate over here? First, let's go and let's try to understand. See, 7 is a prime number. Obviously, no one will be dividing 7 except 7 and 1. So what will happen? These all numbers before 7 will be relative prime to 7. Yes or no? So we can directly write which is nothing but 6. As you can verify that GCD of 1, 7 you will get 1. GCD of 2, 7 you will get 1. GCD, if you want to calculate, I can also calculate such that GCD of 1, 7 you will be getting as 1. Now if you want to calculate here GCD of 2, 7, again you will be getting 1. Now let's see the third one, GCD of 3, 7, again you will be getting 1. Now here you will be having GCD of 4, 7, again you will be getting 1. So what is my point? In this way we can have all the elements. Okay, in this way we can have all the elements. So what is my main concept? My main concept is whenever we will be having any prime number, whenever we will be having any particular prime number, so we can also say that the prime number, it will be what? It will be p minus 1. So here you will be getting what? Here you will be getting p minus 1. So in this way we can understand that totient function of a prime number, that is equals to what? That is equals to p minus 1. So this is basic concept of what? This is basic concept of a totient function. So here you will be getting what? Totient function of a p, which is equals to what? Which is equals to a p minus 1. So we can take with respect to any particular elements. Now let's take other example. Why we are doing all these things? Such that we can come up with one particular formula. So two formula we have already designed, or two observation we have already seen. Such that totient functions are multiplicative in nature, where A and B are relative prime to each other, and totient function of P, which is equals to P minus 1. Now let's take other example. What will happen? Suppose if I want to calculate with respect to what? Suppose if I want to calculate with respect to the totient function of a 49. So suppose if I want to calculate totient function of a 49, let's calculate manually. So here I will be having a 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and likewise you will be getting the last one is a 49. Now if you will try to understand what is my main idea over here, because we have to calculate the total relative prime. Okay, in total relative prime, we have to calculate the total relative prime. That will become what? That will become the totient function of n. That we have to calculate with respect to what? With respect to total function of n. So total relative prime, how we can calculate? If I will get non-relative prime, then out of total, if I will do the minus, okay, out of total, if I will do the minus, then I will be getting what? I will be getting the total number of a relative prime. What is total number of relative prime? That is a totient function of a n. Or another way of saying that, that will become what? That will become, you can say that it is total relative prime, that will be getting totient function of a 49. Okay, so total relative prime is basically totient of 49. So in order to do that, what I will be getting? I will be getting total elements minus non-relative prime, So let's try to understand this. See how many total number of elements that I will be getting over here. Total elements, if you will try to calculate, what you will be getting? You will be getting 49, right? So how many non-relative prime elements that I will be having? So if I want to calculate the non-relative prime, as you can see, there is one observation which is very important over here. What is that? See, if you will try to see that, let's consider one. GCD of 1 comma 49, you will get 1. GCD of 2. So these all are the non-relative prime. 1, 2, 3, 4, 5, 6. 1 is also non-relative prime. 2 is also non-relative prime. 3, 4, 5, 6. Okay. Sorry, these all are relative primes. Which one is a non-relative prime? As you can see that 7 is a non-relative prime, and we want to find out what is a non-relative prime. So 7 is a non-relative prime, and the next, if you will try to understand, then 14 will be non-relative prime. As you can see that it is taking a jump of 7. So from 7 to 14, and the next one will be what? Next one will be 21. As you can see that the non-relative prime, it is taking a jump of 7. So total number of element is 49 and it is taking a jump of 7. So we can say that 49 divided by 7. Okay. So this is actually, what is that? 49. Okay. I'll write in another format so that you will get to know. What is that? 49 minus 7, because it is taking, because there are 7 elements that it will be giving, GCD is not equals to 1, right? So 49 minus 7, 49 minus 7, that I can also write as 49 minus 49 divided by 7, okay? Because it is taking a jump of 7 and then last it will be going and then it will be reaching to 49. So this is my whole idea regarding that. So total relative prime, that you will be getting 49. So the answer you will be getting is basically what you can calculate. Okay, I don't want to go into that answer. I just want to have that observation. That observation is very important. What is that observation? Let's try to see that. Suppose if you will be having what? If you will be having, based on that, for a totient function of 49 can also be written as totient function of a 7 square. Now, if you will try to see that totient function of a 7 square, that can be written as 7 square minus 7 square divided by 7. So this is the basic concept of what? This is the basic concept of a, if you will be taking with respect to what? If you will be taking with respect to the totient function of 7, where 7 is a prime number. Now, if you will try to understand, then based on that observation, I can write as totient function of p raised to a, where p is prime number, that can be written as total elements. What is that total elements? That you will be getting p raised to a. Now, it will always be taking the jump of p, where p is basically what? Where p is prime number. Okay, where p is what? Where p is basically the prime number. So in this way we can understand. So totient function of p raised to a, that can be written as what? That can be written as p raised to a. So this one will become what? This one will become the total number of elements. This is total elements. This is the total elements. Now this one will be saying what? Total non-relative primes. Total non-relative primes. So we got the 3 formula. Okay, we got 3 formula. One is multiplicative, second one is a prime number totient function, and something in terms of raised to prime number. So here totient function of p raised to a, and what it will be saying? It will be saying that total relative primes that I will be getting. So total relative primes over here, that it will be available. Relative primes, okay, that I will be getting. So in this way we can come up with one particular formula, and this is very, very important that I will be getting over here. Okay, now what will happen if I want to calculate something about big number? As I have told you, everything we are calculating in terms of what? In terms of such that we will be getting what? Such that we will be getting any particular number. See, as we know that any number in this positive integers can be written as something in terms of p1 raised to a, and p2 raised to b, and then p3 raised to c, and then dot 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 like that. Now, if you will try to see that, here what you will be getting, where a comma b comma c is greater than or equal to 0, okay, and then p1 and then p2 and then p3, all are distinct prime numbers. All are distinct prime numbers. Okay, see, this formula is very important with respect to what? With respect to any particular number. Any particular number you can write in the form of that. Now, what is the main important concept? I want to find out the totient function of any particular element. So if I will try to write down totient function of n, what I will be getting? I will be getting totient function of P1 raised to A, P2 raised to B, and then P3 raised to C, and then dot dot dot. Okay, this can be any number can be written in the form of this. Either you will take 2, let's take 3. See what will happen if you will take 3, 2 raised to 0, 3 raised to 1, and then 5 raised to 0, 7 raised to 0. So in this way you can write down with respect to any particular number. What will happen if I will take 10? So you can write as 2 raised to 1, 3 raised to 0, and then 5 raised to 1. So any particular number positive integers you can write in the formula of that. So any number n can be represented as P1 raised to A, P2 raised to B, P3 raised to C. In this way you can go and you can try to find out. Okay. So that is my main idea, to find out the to calculate the totient function of any particular element that I will be having over here. Okay. Okay, so as we know that totient functions are multiplicative in nature, so this can be written as what? This can be written as totient function of P1 raised to A, and then totient function of P2 raised to B, and then totient function of P3 raised to C. Okay, right now we are taking only 3 elements. Now in the previous formula, as we know that totient functions are multiplicative in nature, this can be written as what? This can be written as we know that P1 raised to A minus P1 raised to A divided by P1, and then here what you will be getting? Here you will be getting, which is nothing but in the previous slide we have already calculated what is the totient function of P1 raised to A. Okay, now what will happen? Totient function of P2 raised to B. So suppose if you want to calculate with respect to totient function of P2 raised to B, and then here I will be getting P2 raised to B, where P1 and P2 are prime number. Please try to understand that. Now here what I will be getting? Here I will be getting P3 raised to C minus P3 raised to C, and then divided by P3. So right now I am taking only 3 particular elements. So P1 raised to A, P1 raised to A divided by P1, P2 raised to B, P2 raised to B. Now what will happen if I will try to take P1 outside, or you can generalize this as totient function of, okay, you can say that it is totient function of any particular element that you will be having over here. Okay, so in this way we can go and we can try to understand, or you can calculate with respect to what? You can calculate with respect to any particular element. As we know that, see, from here to here what we are writing, okay, what we are writing from here to here is basically totient functions are multiplicative in nature. Okay, they are multiplicative in nature. Or what is the reason behind it? The reason behind it about a totient function, such that totient function of A into B can be written as totient function of A into totient function of B. So from here to here we can easily write it down. Okay, no problem into that. So let's consider this is the whole situation that I got. Now what I can write over here, I'll write something like that, such that totient function of n that can be written as, which is nothing but P1 raised to A, and then P1 raised to A divided by P1, and this whole thing, after that what you will be getting? After that you will be getting P2 raised to B minus P2 raised to B divided by P2, and then after that what you will be getting? After that you will be getting P3 raised to C, and here also P3 raised to C divided by P3. Now what will happen? Try to take common something in between. Now if I will be taking P1 raised to A, then what I will be getting? I will be getting 1 minus 1 upon P1. Yes or no? Right? Yes or no? After that what will happen if I will be taking P2 raised to B? So here I will be getting 1 upon 1 minus P2. Okay, and then after that P3 raised to C, what I will be getting? 1 upon 1 minus P3. Okay, right now I am taking only 3 examples or 3 elements so that we can cover all the things. Now what I will be getting? I will be getting P1 raised to A, and then P2 raised to B, and then P3 raised to C. Now here I will be getting, which is nothing but P1 minus 1, and then here I will be getting P2 minus 1, and here I will be getting what? Here I will be getting P3 minus 1, and then this whole thing will be divided by P1 into P2 into P3. So this is a formula that you can understand with respect to what? With respect to totient function of any particular thing. So here what I will be getting? Here I will be getting totient function of n, and this whole thing can be written as n. So this one will become n, and then what I will be getting? I will be getting P1 minus 1, and here what I will be getting is P2 minus 1, and here I will be getting P3 minus 1. If I will be taking with respect to 3 element, I will be getting 3. But what will happen if we will be taking anything? So this is P1, this is P2, this is P3, and then likewise. This is a common formula in order to calculate what? In order to calculate which is nothing but totient function of any particular element. Okay, so I have given you the enough proof such that you can calculate the totient function of any particular element, and this is the formula that you will be getting over here. Okay, so in this manner today we have completed one particular topic. And what is that topic? That topic is basically totient function of n. In this way we can calculate everything that is related to that. Okay, so that's it for the today. So we have already covered all the things. As we know that the Gradeup is coming up with a large amount of experience, the best CS team that you people can have. Okay, and here we are having the different batches. So right now there are certain batches are going on, and then there is also called as one weekend batch. So those people who are into IT professional, or those people who are working somewhere, or those people who cannot attend the classes regularly, you can come up with the weekend plan. So weekend class which has already been started from where? On 13th of March. Okay, right now discrete mathematics is going on, so you can take a subscription into that and you can take the admission. So March 13, one weekend batch has been started. So those people who wants to take the admission in weekend, so they can contact on this particular thing. And if you want to have any particular assistance such that you want to join any particular batches, then you can go and you can join that particular batch. In this way you can understand the whole particular thing. Okay, so these all are the faculties, you can say that schedules that is going on. Okay, these all are the rankers that we got. Okay, so that is why the Gradeup structured plan is very important in order to take that. So here we'll have different types of structure plan. So first of all, like this session guys, and then you can share this session with those people who wants to understand about it Euler totient function. So in this way we can stop the session over here. Okay, thank you so much for watching this video, and if you like it, then you can share with all of your friends, those people who have a problem with respect to what? With respect to the Euler totient function. So we'll come up with another concept, maybe in the following days. Thank you so much.